Warm welcome to this Jove training webinar on designing engaging physics courses using videos. My name is Abigail D'Souza and I'm a curriculum specialist here at Jove. It's truly a pleasure to have you all here joining us today. Thank you for taking the time to be with us. Joining me on this session is my colleague, Dr. Stephen John, the subject matter expert, who will be providing valuable insights into the realm of the physics world. I also have Dr. Preeti Sridharan joining us today, who is also a subject matter expert here at Jove. And today we are also privileged to have with us a distinguished speaker who is not only an expert in the field of physics and engineering, but also a shining example of one's contribution to the field of science. A very warm welcome to you, Dr. Josh Robertson. All right. Can someone confirm whether you can see my screen? Okay. So, firstly, we are here to explore the world of Jove and its pivotal role in designing engaging physics courses. So, today, to do that, what we'll do is we'll have an overview of what Jove is and what we have to offer, followed by Dr. Stephen, who will guide us through the various physics collections. And thereafter, we have Dr. Josh, who will share his valuable experience in using Jove physics videos in his foundation year courses in engineering. Finally, we'll learn how to insert these videos into learning management systems such as Blackboard, Blackboard Ultra, as well as Moodle. And finally, we'll wrap up with a question and answer session. So please feel free to post your questions in the Q&A or the chat box, and the same will be addressed towards the end of the webinar. So let's start from the word itself. What is Jove? The acronym, it stands for the Journal of Visualized Experiments. What we do is we provide video resources for education and research purposes. And Jove is in fact the world's leading producer and provider of STEM videos. And over time, it has become a leading scientific video creator, which makes teaching, learning, as well as practicing science more efficient, effective, and engaging. So where are we today? We have around 18,000 videos in our library. I'd like to say it's a growing library because we have around 1,200 videos that are published every year with 1,000 plus subscribers across the globe. All our videos are available 24/7, and they are available in 14 different languages in terms of translations and voiceovers. So the idea behind Jove is simple. It's visualizing concepts through videos that enhances understanding compared to just reading alone. And it's in fact scientifically proven that a visual simulation leads to better understanding as compared to just text alone. So here, if you look at this particular slide, you see a text article as well as a video. So of course, to understand the concept better, we would always like, so that's where Jove comes in. So today, like I said, we have with us Dr. Stephen John, the subject matter expert, who will take us into the realm of physics and engineering within Jove. Over to you, Stephen. Thank you.
Thanks, Abigail. Let me quickly share my screen. Can you see my screen?
Yes.
All right, perfect. All right. Good morning, good afternoon, good evening, everyone. Thank you for joining us today. I'm Dr. Stephen John, subject matter expert. I'm excited to guide you as we explore the fascinating world of physics collections. Before we dive into the core collections or the core physics collection and all that, I would like to quickly introduce you to our website. So our Jove website is basically divided into two main sections. As you can see on the left, we have research, and on the right side, we have the education collection. So under our research collection, we have video journals of various subjects. And we also have Encyclopedia of Experiments, which are experimental procedures aiming at explaining the fundamental concepts in research techniques. So this would be very helpful for students who want to do some research, also the graduate level students. On the other hand, we have the education collection, which mainly acts as a tool or a teaching tool on focus on key concepts. So when I say key concept, the first part of our education collection is very important. So it is our core collection, which focuses mainly on the key concepts using animated video lessons and which are shorter in duration. The second collection we have on education is our science education collection, which is a blend of theory of the concepts uh, as animations together with practical applications in the research setup. So this would be very helpful for students to learn about an experiment and to conduct it using the animations. The last part, what we have in our education collection is a lab manual. So the lab manual is instructor and student-centric videos. So here we have three subsections. So number one is the concept video, which focuses on the concept, explains the concept to students, and instructors can have a look. And the next subsection we have is the protocol, which the students can use while they conduct their experiments. And the third subsection in lab manual we have is the instructor prep video. So this one is very helpful for not just the instructor as well as the students to prepare the materials which are needed to perform experiments. So this is the main two sections of our Jove website. Now let's dive a little deeper into our core collection. So as I mentioned, our physics core collection is an expansive collection. It has about 33 chapters, 498 videos in 14 languages. So we have subtitles in 14 languages, which helps students who can learn in their own native language to understand and grasp the concepts. So the core videos are 90 seconds in length, and it is framed with an idea of one concept, one video. On top of that, we have 99 scientists in action videos. So these videos are real-time applications of some of the key concepts of what we discuss in the concept videos. So this would help students to apply these concepts in real time. So our videos are really engaging. So we have like animations which explains these concepts in a clearer way, which helps the students to enhance their comprehension and helps them to uh, helps them to know what they're learning. So it helps them to redo or conduct an experiment again and again without any difficulties. So our core collection is mainly focused on the undergraduate physics and engineering courses. And also it meets the global curriculum requirements and learning objectives. So any student from any country who want to know or learn physics, this would be very ideal, especially for undergraduate physics and engineering students. So let me go into detail. So in our core collection, we mainly have the concept videos. So when we learn the concepts, it is of course difficult because physics being more rely on more on the mathematics side. We should have mathematical skills to solve problems. So we focus on two main things. After we learn the concept, we can solve the problems using the equations. So here you can find how to tune a guitar string. So the physics behind tuning a guitar is explored in this video. And in the second example, you can see how the video of applications of circular motion is used in everyday life. So our core collection mainly focuses not just on the concepts, but also to learn how to solve problems using the physics concepts and also how to apply it in everyday life. So now let's focus on our content. So as you can see, the 33 chapters we have in our physics collection is divided into 5 main sections. So it starts with the foundation of physics. So to learn any subject, you need to have a strong base. So that means your foundation has to be strong. So we start with the foundational concepts, starting with measurements, vectors, and scalars. And then, so that's dealt in chapters 1 and 2. And as we go to the next section, mechanics, we have chapters 3 to 13, which focuses on the classical mechanics, the kinematics, energy equations, and also fluid mechanics. In the next section, oscillations and waves, we have chapters 15 to 17. So these chapters focus on the oscillations, how to learn the equations of waves, and also the harmonic motion equations, which are very difficult to understand, but it is made in a simpler way that everyone can understand these equations. And we also deal with the sound. So the next section, we have thermodynamics, where we have chapters 18 to 21 covering all about temperature, heat, kinetic theory, especially how the gases behave, and also the laws of thermodynamics. And in the last section, we have chapters 22 to 33, which deals with electricity. In particular, we have the differences between direct current, alternating current. We also deal with magnetism, magnetic forces, electromagnetism. So we have covered all these concepts. So we have a bunch of video lessons for all these topics, which will be very helpful for students, not just to understand the concepts, but also to solve problems and also to apply in real life. So the next set of core collection we have is our core mechanical engineering collection. So in our core mechanical engineering collection, we have 11 chapters, which has about 149 videos. So the 149 videos are focused on fundamental physics, statics, vectors, equilibrium, friction, center of gravity, etc. So these are made in a way that engineering perspective of physics concepts are dealt here. So that means students who take engineering courses, specifically the ones who also are getting ready for competitive exams, this would be an ideal set of bunch of videos to have to learn all the concepts, and also the real world scenarios are dealt here. So as we finish our core collection, let's move into our science education collection. So as I mentioned earlier, our science education collection is a blend of theory of the concepts and practical applications in the research setup. So we have about 30 videos on our science education physics collection, which focuses on classical mechanics, thermodynamics, electrostatics, magnetism, optics, and about electrical circuits. So these videos are very much helpful for students to conduct experiments, specifically when they want to perform this experiment with a set of protocol and to find out problems using equations. These would be ideal for all the students learning about these concepts. On the other hand, we have the science education engineering collections, which focuses on the concepts of physics and applications. So when I say applications, you can see we have electrical engineering and mechanical engineering. So our science education engineering collection is not just physics, but also the applications of engineering subjects, mechanical and electrical. So likewise, like science education physics, we have 30 videos here covering all the key concepts and topics in engineering. So we have all our resources, and how can we use our resources? So as you can see on the first part here, we have comprehensive video playlists specifically made for topics like mechanics, electricity and magnetism, waves and optics. So these are playlists which are curated specifically with videos from concepts and all the way to applications. So if you want to explore more, we'll be going into details when we finish our presentation. So we have videos, comprehensive video playlists here. Also, we have books which are ready to be used. We have chapter-wise video playlists for textbooks which are widely used. So you can see here some examples. So we have about 11 books in total, which would be very much useful for students as a supplementary material to use in their class and to perform their experiments and conduct research. So that's pretty much about our collections, say the core collection and the science education and the research. So before we finish, I'd like to share an analogy here. So the picture here, as you can see, has a mirror inside an elevator. So you must be wondering, why do they have mirrors in elevators? I think now we can answer that question, but let's go back to the mid 20th century and find out what they really did. So at first, when the elevator started being popular, after some time, there was some questions among people that, I mean, a problem which was like, why the elevator is taking so much time to go between floors. So the problem was presented to the engineers, and the engineers started looking at it, and they wanted to find out a solution to this problem. So they contacted a psychologist into the team, and they were looking at this problem and tried to find out what really happened. So they came to a point that as the buildings are getting older, we cannot fix this problem because it needs much more machinations and work. So they thought we have to find out another solution. So they came up with an idea that, so first they wanted to confirm whether the problem is there or not. So they found out, yes, it is taking a long time, but we have to find a solution to this one. So they came up with an idea of installing mirrors. So when they installed mirrors, they had people can look at something fascinating. So what's more fascinating than looking at themselves? So in that case, the problem was solved, because when they started entering the elevators, they started looking at themselves. So the problem was pretty much solved there. So the bottom line here is, when you reframe a problem, you have different solutions. So as we all know, we learn in physics is we have a lot of problems, and students face a lot of problems learning the abstract concepts, and also needing for mathematical skills to solve problems and equations, and also the collections where we have lessons, say, from different topics, like from simpler topics to say difficult topics. It's hard to understand. So here, Joe is our mirror. So it solves the problems by having simplified videos with animations, which can help students to understand the concepts in a simpler way. And also we have applications-based videos and also real-life examples. So as a whole, Joe is a mirror solving your problem. So thanks for giving this opportunity. Thanks for your time. Over to Abigail.
Thank you so much, Stephen. That was really insightful, and thank you for taking us through the entire tour of our physics collections. And yeah, I love how the way the mirror shrinks time. So yeah,
Sure.
and how we can always reframe a problem, and that's where Jove comes in.
Absolutely.
All right. Stop sharing. Perfect. Just give me a. All right. So now we have, like I said, we have with us Dr. Josh Robertson, who is going to be sharing his insights, who has used Jove in his own classes and in fact, his foundation year in engineering courses. Dr. Josh Robertson joined the University of Southampton in 2021 as a senior teaching fellow and is one of the leads of the engineering foundation year programs. Before joining the university, he worked at the University of Portsmouth as a programming and electronic engineering lecturer in the School of Energy and Electronic Engineering. Josh completed his PhD in 2018 at the University of Kent, researching automated border control systems and intelligent biometric sensors under the supervision of Professor Richard. During his PhD, he also worked as a graduate teaching assistant, teaching several modules throughout the school. Thank you so much, Dr. Josh, for joining us and sharing your experiences in using Jove videos. I'll hand over the stage to you. The virtual stage is yours.
Thank you, Abigail. Yeah, hi everyone. So sorry, I'm in the big lecture theatre. I'll wave to the camera right at the back. Can you hear me okay on the screen, Abigail? Yes,
Yes.
brilliant. Let me share my
Clear.
screen and just let me know if you can see this okay. And I will start presenting. All good?
Yes, all good,
Yes.
Josh.
Brilliant. Okay. So yes, hello. I'm Dr. Josh Robertson. I'm a senior teaching fellow here at the School of Engineering at the University of Southampton. A lot of this has just been covered, so I'll blast through this first slide. So my background is very much in electrical engineering. I teach mostly electrical and electronic engineering, but it has our physics concepts. I'm a senior fellow of the Higher Education Academy, and as my background alludes to, I've been teaching students in higher education for over 10 years now. I do have a research background in biometrics and usability, but more recently I've been moving research into a bit more of a pedagogical research area. So I'm very much interested in engineering education and advancing engineering education, looking at assessment and feedback models. And I do a lot of work with students transitioning into higher education. So I'm gonna talk about that in a bit more detail, but that's some of my current research areas that I'm now leaning towards. So here at Southampton, I look after the engineering foundation year. This is an integrated course that feeds into 17 different disciplines in our school. So students join foundation year, and if they pass and they complete all the modules, they can progress into very different disciplines across the faculty. That does include most of our engineering courses. So I'll talk about the School of Engineering in a second, but that will include engineering courses, computer science, maths, and our physics undergraduate courses. So the students I deal with are transitioning into lots of different pathways. On our course, we have around 90 to 120 per year. Kind of fluctuates a little bit, but that's a typical number. I also teach on our part one, that's our year one, if you like. Part one in our School of Engineering is shared between all disciplines. So it's a scary number, 600 students, but that is broken down into mechanical students, aero, ship science, maritime, medical engineering, and so forth and so forth. So they all share, for the majority of it, part one engineering, and they'll have their own subject discipline modules. And I teach mostly the electricity and electronics side of that part one. So a lot of my students feed into that stage one of the next course. So quite a few students at Southampton. And on the right, you just kind of get a sense of what our campus looks like. Very traditional lecture spaces, but big rooms for our big cohorts. Our learning philosophy at University of Southampton, and essentially this is a slide that our students receive at the start of the year, is probably much like traditional universities. We have lectures, and those lectures are very much designed to introduce and scope out a topic. So when I'm teaching electricity to electronics, I might talk about capacitors, and it's meant to be a starting point for our students to understand the basics of capacitors, but we ask them to do some private study to find out more about capacitors. So we might do some exercises. We'll talk about the concepts of charge and discharging and transients. And if you want to find out more about how capacitors work in real world applications, then you've got lots of literature out there and videos and resources that you can go to find that. We'll come back to that bit in a bit, because that's obviously where Jove's going to help to come and cement some of those topics with our students. But these are meant to feed into each other. So if students been given a starting point of a lecture, then there should be some follow-up. But likewise, there should be a bit of reading prior to attending classes to make the link between the two. They all link into our labs and workshops. So both at foundation year and part one, the students sit a class or attend a lecture. They're expected to do some private study, and then they come and test their knowledge and understanding in our labs and workshops. And over the year, they obviously will have some form of a test, assessment, and that's our opportunity to provide feedback on how to do things better. But we're also testing how well they understand a certain topic. So it's a bit of a life cycle of learning. I'm sure we've all kind of had an experience of this type of learning. But this is how we communicate to our students. This is the life cycle of what we want you guys to do in your course. So I'm going to talk about Engineering Foundation Year a bit more specifically. That's the program I lead, and that's one I do a lot of design and changes within. The Engineering Foundation Year, I'm going to abbreviate to EFY. It's made up of 6 modules. We have core subject modules, so we have electricity, electronics, mechanical science, engineering principles, which is essentially physics, mathematics, the core maths module. And then these are the core subject modules, but we also have 2 modules that work on academic skills. So the first part of academic skills is about presentation, error analysis, looking at different types of data, and then it builds into research and writing skills, and then there's group work. And then we have a coursework module, which is the module that contains computer programming elements and the labs that students do. These labs are based on these 3 modules. So the experiments that students do are fairly straightforward at the start of the semester. So perhaps a simple pendulum, Hooke's law, maybe something to do with multimeters and power supplies and circuitry. But as we progress throughout the year, the experiments themselves build in complexity based on the subjects that the students might be learning. So this might be specific heat, specific gas, one about engineering principles labs. And we build up to some more advanced circuits. So this is an audio amplifier students work on around halfway throughout the year. But yes, it's following a series of labs, and the students build up their skills throughout the time in their module. So the labs are a big part of our learning process here in Foundation Year. And most of our modules are based on the following structure. So each of those core subject modules, the electricity, electronics, the engineering principles, with the modules I teach on a day-to-day basis, each week we have 2 one-hour lectures. The students have 2 one-hour tutorials / workshops where they put their knowledge into practice. They're expected to answer questions, and a bit more of the, we build up the complexity to more problem-solving based scenarios. And kind of exclusive to our foundation year, we have support sessions. So if students feel like they just need a little bit more time to work on a subject or a bit of private study, we have these drop-in sessions where we have support tutors. The support tutors are very much there to just give the students confidence on the subjects that they're working on. So that's kind of exclusive to our foundation year. Our part 1 students just have the lectures and the tutorials. Typical lecture theatre, we've all seen one. I'm in one now, kind of. Students are in person, and I will be at a pedestal, very much like I am now, and given a presentation. But we're trying to work away from that a little bit. We're trying to make a bit more of a sort of a learning community where students are expected to be involved with the process. So I'm going to talk about flipped learning later on in these slides, and our kind of expectations of how students learn and how they engage with each other in a classroom environment. Students are communicated their sort of module layout. So we give per credit or per 15 credits of a module, we roughly say that's 150 hours of your time. And this is what we're asking of you. So we ask them to do follow-up work, preparation for scheduled sessions, and we ask them to please come to classes and show us how you're getting on with things. So each module has this kind of study guide, if you like, and a bit more of a breakdown of what a module might look like week by week is we provide this essentially a spreadsheet, but a module profile of what each student will be doing. And we set some expectations that they probably should be doing some reading and activities outside of class. And one of the things I'm quite passionate about with my foundation years is actually guiding them on that journey. When we have students come definitely for a foundation year, but even at our part one, students are transitioning and they've come from maybe a school environment where a lot of resources and information is given to them quite, quite regularly and in quite a sophisticated way. At university, that changes a little bit, and we ask students to, you've got to be able to apply the knowledge and the understanding in a variety of different scenarios. There's not just one solution that you might come across. So we try to kind of scaffold and support our students throughout their learning journey to begin with. And we also have our virtual learning environment. We use Blackboard Ultra, and that's where all their resources are hosted, or all their starting points, I should say, are hosted. So we upload their slides, questions, any videos that we think are of interest, and additional content that the students might be interested in. But we also ask them to share things that they find online. That does tend to be, TikTok videos or YouTube videos, things that they found that are interesting, which I'm not always keen to put on my Blackboard because I'm not quite sure the sort of the value or where that's been obtained from. But yeah, it's very much, we would try and design our course to be a learning community rather than the sort of teacher-student relationship. So as I've sort of alluded to, our engineering foundation year students are from a variety of backgrounds. So I'll explain the foundation year in a bit more detail, I suppose. So if students were coming to us at part one, they are most likely have done maths and physics at some point in their college and prior education. And they will have the grades required to go straight into part one. The students that we take at foundation year are not typically students who hold a maths and physics type background. They may have done some maths, but no physics. They may have done some physics and no maths. Or I've got some students on my course who have done completely different subjects. They may have done photography, Spanish, and business studies and have no maths or physics. So one of my pain points, if you like, or something that I have to constantly be thinking about is how do I support my students coming from these variety of backgrounds? And it's not just the subjects, we have mature students, we have students who might be carers, we've got a whole array of widening participation areas where students are coming through our foundation year, and we need to think about how we support those students as well. Most of our students on foundation year struggle or can struggle with different concepts on different modules. So I might get some students who've had a little bit of electricity, electronics background and are quite strong in my module, but in a mechanical science module, they might find those concepts really difficult because they've not experienced them before. Likewise, for students who may have done some maths, might find some of maths fairly straightforward, but then the application of the maths in their engineering and physics-based modules is really difficult for them. So the core concepts can be very tricky for some students rather than others, but we have to establish a baseline. We have to get everyone on the same page as we progress throughout the course. We also need to consider that our students coming into foundation year are going to be transitioning into part one students, with part one students, I should say, and those part one students, so the students coming straight into their first year of university, will have a very strong physics and background and won't be struggling usually with the core concepts that they've been studying for several years already. So our job is to make sure that they transition fully into university, they know the support systems that are in place, and they become, or they're very much on that journey to become independent and resilient learners that can survive as they progress into that part one. They're my main my main pain points. I've got some reflections from some of my students. So in my electricity electronics module, I ask for students to keep a learning diary, so a bit of a learning journal. So at points throughout the year, you just say, hey, how are things going? Are you enjoying the content? What are you doing outside of class? What kind of things are you working on? So here are just a few examples that I'll let our attendees look into. I won't read them fully out, but the general message that our students are communicating is note taking is very difficult at points, especially when a lot of content that Josh may be teaching is flying out. There's got 20, 30 lecture slides. There's a lot going on. Balancing outside activities, so students have jobs, students have lives, and balancing that in part of their studies is also very difficult. So finding ways to condense that information and engage with that self-study is really important, but difficult at times. There's a common theme as well you're going to see probably in the next paragraph is, where do I go to get material? So Josh has given me some insight into a particular component or a circuit, and I now need to do some self-study. Where do I go to do that? Do I go to the YouTube, or do I use a book that Josh has suggested? And this last one here touches on that a bit further. I thought this sentence towards the middle is quite interesting. So although I go to the lectures, sometimes I don't understand what's being asked. I have to do some reading before and after class to consolidate that learning. Ultimately, that's what I want my students to be able to be doing anyway. But I feel like some of our students, especially towards the start of the semester, struggle with knowing how to do that. So presenting some work and presenting some guidance for them from trusted resources is really important for us as educators at the university. So how did I hear about Jove? Well, essentially, we were sort of contacted, I guess. Our university holds a license, so we have access to all Jove's materials, which Stephen just went through. John's, but we essentially, sorry, I'm just going to minimize something on my screen. Essentially, we were looking for something that was accessible for our students. It was engaging for our students. We'll talk about the core sort of aspects in a second, and the animations that we were really desperately looking for. And we wanted to help demonstrate concepts that I can talk about in my class, but fundamentally are quite hard to visualize for our students. So being able to simply demonstrate a concept to support the students' understanding of that concept is really important for us to work on. So our notes, the kind of our material, if you like, that we provide students are maybe written notes, lecture slides that are quite in depth. And this might be something that an academic has put forward themselves. They may have wrote this at some point. This is actually one of my colleagues who's wrote essentially a book themselves for the course. But Jove videos have been able to break that down into more bite-sized content with the animations. And the accessible part, which is very key for our students, I think we've got about 80% home students and around 20% international. So looking for accessible content was really important for us. So options to change language, to have captions, to have a transcript were great features that we were simply missing. So going back to these old notes here, they're quite condensed. They're written to a high language, but still conceptually it's quite hard to maybe convey these concepts. So working with the Jove videos and coming across these were ideal and bite-sized enough that our students were going to be quite happy with implementing them. So how is Jove helping with our subjects? Well, it's definitely enhanced with visual learning. So if I'm talking about circuits in my class, we talk about, I draw circuits on the board all the time, and I plot arrows indicating the flow of current. For example, there's a video showing current moving around a circuit, flowing around a circuit, then that immediately helps the visual aid of what concept I'm trying to talk about. We're also trying to foster this private study. So having these accessible videos immediately embedded or linked or provided as a playlist on our Blackboard site immediately gives students the idea, okay, these are the things I should be doing on a weekly basis. So I talked about earlier about that guidance, that initial guidance for students. We want to get them on this journey and to get them familiar with this concept. And I think also there are some good things on YouTube, but as an academic, I want students to learn it, learn content from a trusted source. So whether that's me or someone that I trust, the content that I provide on my virtual learning environments are resources that I know that are high quality and value to the students. And YouTube, not always sure of its authenticity. So we've, in areas, embedded videos into our Blackboard. This is actually our last layout of Blackboard. So we're rolling over to an Ultra layout at the moment. So we have embedded videos, but we also do look at the statistics of student engagement with our content. And you can see here that this is a particular week in November last year. And on that particular day, around 120 hits were on this movement on inertia video clip. So we do some sense checking to see if students are actually engaged with our content. And over its time, we can see what students are accessing and how many students are accessing it at a certain point in time. And we're looking at what days of the week students are also interacting with this content. So their class is on a Tuesday, as you might have guessed from this last picture, but we can see that students are actively looking at these videos and content outside of class and on different days. I'm going to break down how we use Jove in our three main areas that I talked about at the start. So lectures, private study, and workshops and labs. So lectures, we're starting to introduce flipped learning activities. Just for defining that, I suppose, flipped learning is where we might provide some students with some reading or some content prior to the class, and then they're expected to come into the class with a general idea of the topic and concept before the class. And then in the class, we might do activities where we test their knowledge and see how well they know and have more of a formal discussion amongst that. So we're now introducing flipped learning activities where we're asking students to do that for us and to try that out. We use videos to recap previous content. So I've recently started teaching alternating current, and the concepts of capacitors and inductors, which I've taught earlier in the year, I am using Jove videos to provide a short bite-sized clip of a recap of how those concepts work. And we are also showing the practical demonstrations. So the higher concept lab experiments and applications that we have access to Jove, we do show those to students during our classes. So on my new Blackboard Ultra layout, we have the link to Jove, and these are playlists that I've created. So I've curated videos that are relevant to that week's topic. And this is just what it looks like on a mobile phone version of our Blackboard Ultra, but it's made it a bit more accessible and easier for students to learn as a transferring between devices. What's really interesting as well, going back to this picture, is that students are able to mark their progress, so they can track whether they've completed this task or not. And I've got a little bit of data to share later, but we're actively looking at that as well to see what our students are doing on a regular basis. In the private study, we do signpost students to go and watch these videos, so there is an expectation that they should be watching this content. We ask them on occasion to find their own videos that they think are useful and share that with their cohort. So they are directed to Jove and they can go find videos, and we have discussion forums where we can share content that we found that might be interesting. And as I said before, in the new Ultra layout of Blackboard, our students are now starting to mark their progress as they proceed throughout their courses. So that's the things that they're encouraged to do. We are starting that encouragement. So that's been more of a semester 2 thing. We're about 3 weeks into our semester 2. So you can see here that in our semiconductor week, which was actually a week ago, only 6 students marked that they completed the study, but I can see that a lot more students access the video. So we're just trying to join the message up with students tracking their progress. They don't have to, but it's good for them to do so. It also helps us to identify where students are getting on with their self-studying.
Perfect. All set, Josh.
Okay. So Jove is starting to be used in our labs as well. So some of the work that I'm working on this year is introducing pre-lab material to our lab experiments. As we talked about earlier, the lab experiments for our foundation year students start with some simple concepts like Hooke's law, simple pendulum, specific heat and specific gases. We typically see in our lab exercises that students kind of turn up to the lab and may not have a great understanding or idea of what they've got to do in the lab. So we're trying to encourage engagement with some pre-lab material. The labs are based on the content that they do in the class. So they have the lecture, and at some point in a few weeks' time, they do have the lab that might be based on that content. But typically, we're finding that students are not maybe spending the time preparing. That could be for a variety of reasons, but we are working on pre-lab material. And something that we work on early on in the semester is the importance of data, looking at accuracy and precision, random and systematic errors, everything to do with data collection when we are scientists and engineers. So having those resources and videos is our kind of starting point in our pre-lab material, ensuring that students understand the importance of doing so. And we've found there are quite a few specific applications and lab procedures that are probably of interest to our students. So here, electrical safety precautions and basic equipment gives students an overview of power supplies and multimeters and risks of working with electronic-based circuits. So that has been very interesting and helpful to have a ready-made video presenting that information. Something I've been working on are ThingLink scenarios. So essentially, these are tours, if you like, or scenarios where students choose a lab that's coming up, and they will go and explore that case study. And you can see here on the left, labeled EE1, there's me presenting the experiment itself, and then straight after there is a video linked to Jove, and this is where students will have that video from here about electrical safety precautions and basic equipment. And in ThingLink, we can set up various quizzes, both open questions and closed questions, like multiple choice questions, where students can interact and demonstrate that they've understood the content that's been provided in the scenario. So this has been really received positively by students. They really appreciate seeing what the lab is about and get an understanding of equipment and materials that they'll be using prior to coming to the lab. And that's been really easy to embed. So we create a scene and we take the Jove link and just embed it, and it will run much like our Blackboard videos where it's implemented straight in. And essentially inside the ThingLink scenario, it just comes up with straight to Jove video. So that's been very good to kind of have it all in a single place. This ties in with some of my educational research. So I've been looking at the applications of digital badges. So students do this pre-lab material. If they spend 10-15 minutes going through this scenario, they're awarded a digital badge at the end of it, and they can use that on the social media. They can create digital CVs. It's a certification to say, yes, you've been a brilliant student and you've gone above and beyond. Probably worth saying that the digital badges aren't worth grades, so they are formative opportunities for feedback. But that they've been really well engaged with by the students. Around 80-90% of the course are actively engaging with the digital badge system, and that's not the only digital badge we have, but there are different badges for different things inside our labs, and one of those is this lab prep badge. So that's where Jove Videos has been used to help support that. I've been collecting some feedback from students. So ultimately, they're really happy and appreciate the animations that have been provided in the core videos that we have been linking on Blackboard. They've said that that really helps with their understanding, and they appreciate animation. So actually, I was talking about heart defibrillator earlier on in my course when talking about capacitors. Unfortunately, I don't have a heart defibrillator that I can bring into class and try out on a student, but I can show a handy video about, this one's a pacemaker, but I can play these or link these videos to students that are going to conceptualize and understand the concept a bit more visually. So students have definitely been picking up on that. That's been a great resource. They have found the applications, so the more scientific and advanced applications that we do have links for, that they do find that they do find that difficult to understand, but they do find it interesting. So seeing how a basic concept of a capacitor is applied in a real world application or in more scientific approaches that might be a bit more specialized than where they're currently at in their studies, they do find that really interesting. They do comment on that, and that often has informed students to go and explore that a bit further. So it has given them something to think about and to explore. Something that's worked really nicely, which is a bit of an offset, is that because these videos have the transcripts and the information at the bottom, and it's written to a scientific standard because it's been it's been researched and approved by staff members from Jove. It's actually introducing them conceptually to the aspects of scientific writing and research. So having sort of further resources to go and explore and look at the way the concepts have been talking about, as it opened their eyes up a bit more to the level of writing that we are expecting from them as they progress throughout the degrees. So that's been a great concept as well. My last slide, suggestions and take-home messages. Well, my students, at least, appreciate the following. They do appreciate animations and recaps on core principles. So having those embedded in my weekly structure, they've liked that. So if a new topic's coming up and it's based on a previous topic that we covered earlier in the year, then having those recap videos, those bite-sized chunks from the core library has been really, really appreciated. So I'd recommend doing so in your own modules and classes, and offering this guided learning support. So I wouldn't expect my first year students to come in and know how to privately study, and I wouldn't expect them, well, I'd expect them to be able to do bits, but giving them some starting points and guiding them on that journey, I think is really important, and setting clear learning objectives. So if we are asking them to read or to watch a video, what should you learn? What are the things that we want you to get from this video? If you watch this video on capacitors, you should be able to then apply this theory of transient behavior into the workshops and questions that we have for you after. So presenting clear learning objectives so they can check their knowledge and check their progress as they proceed has been really important. That's all I've got today to share. So thank you so much for listening. I'm happy to answer any questions. But yeah, hopefully that's been an insightful journey into how we've used Jove in our courses at Southampton.
Josh, thank you so much for sharing your, can you hear me?
Yes, yeah,
Okay,
good.
perfect. Thank you so much for sharing your experiences and how well you have used Jove videos, in fact, to enhance your courses. Particularly, I like the way you showcased the life cycle at University of Southampton and how it has enhanced your engineering foundation year. So, of course, it's evident from your presentation and the way you have showcased your dedication to providing an enriched learning experience for students is truly commendable. Your presentation, I must say, has indeed sparked new ideas and perspectives. And I'm sure many of us are eager to explore incorporating Jove videos in our own teaching and practices. Thank you so much, Josh, for your time as well. All right, now coming to the part where how does one access Jove resources and how you can insert this into your own learning management systems. To get started, always make sure you are. So first thing, just type in jove.com and it will redirect you to app.jove.com. To sign in, simply enter your institution email address and password. If you do not have an account, simply click on create an account. Once it's done, simply sign in and your name should feature at the top right-hand corner. That's the first step. Once later, what one can do is you can simply use the search toolbar here and simply type in keywords like you would do in Google or any other search engine, and it will give you a list of all research related articles as well as education. Alternatively, we have various tabs on top. We have the research tab as well as the education. Within research, we have several subject areas, which includes the Journal of Engineering. The journal is like any other journal article, just that accompanying each of our journal articles is a video, which explains what research one is conducting in the lab, followed by the actual experiment or demonstration in the lab. So you can browse through that at leisure. And now coming to education. That's the main highlight for today's session. We have the Jove Physics and Engineering, which currently houses Jove Core and Jove Science education videos. Let's look at how they are different. Jove Core videos are typically introductory videos, which we call as a video textbook. These videos cover up key terms and concepts. We call it a video textbook because it ranges from chapter 1 to chapter 33, or several chapters basically. And within each chapter, we have several videos, just covering up key terms and concepts, very short videos ranging from 1 minute to 3 minute long. They are all animation based. If I just go to models, theories, and laws. So you have a video, you have a little bit of text reading. You have the option of embedding, sharing on social media, add to favorites, and also creating your own playlist. In addition, several other features is the speed regulation feature, as well as a closed caption in several other languages, in 14 different languages explicitly, making it easier for our global audience. That's a bit on the Jove Core. In addition to animated videos that you see here, we also have the Scientists in Action tab. This basically refers to basic applications related to the various key terms and concepts covered up here. The Scientists in Action are real-time lab experiments, either from the journal collection or from a science education collection. So these are fairly longer videos as opposed to the ones in key terms and concepts. That's a bit on the Jove Core physics collection. In addition, within physics, we have the Jove Science education videos. That's here. These covers up various protocols and concepts. We have Physics 1 and Physics 2. Physics 1 covering up classical mechanics, thermodynamics, etc. Physics 2, on the other hand, covering up various concepts in electrostatics, optics, and electromagnetism. How are these different from that of Jove Core? These videos comprise of animations as well as real-time lab experiments. The features remain standard throughout our education videos, but in addition, so one can just navigate within the chapter here on the top right-hand corner. So that's a bit on our physics collection. Coming to engineering. Within engineering, we have the Jove Core Mechanical Engineering. Again, video textbooks basically covering up key terms and concepts. Our core videos cater to the needs of undergraduate level students or more as a refresher. Coming to science education engineering, covers up various topics within engineering. Again, real-time lab experiments. Let's look at how one can insert these into your course management system. First, always make sure you're logged in. Your name features at the top right-hand corner. And if you are a subscriber to Jove, your university subscribed to Jove, simply go down to if you're on campus, you'll be able to watch the video even without having to create an account. But if you're off campus and you would like to insert this into your learning management systems, make sure you have created an account and then insert into your course pages. Go to a video of your choice. First step, click on embed video. The second step you would see is the copy embed code option over here. You click on copy embed code. Once you have copied, you can simply go to Blackboard. So this, I'll show you three LMSs: Blackboard, Blackboard Ultra, as well as Moodle. Let's take a look at Blackboard and Moodle. So Blackboard, you go to Blackboard course page, click on build content, and here you'll click on item. Enter the title of your video. I'll just put it as test. physics. And here within this, you will see source code. So you click on source code and simply Control V and save. Similarly, in the case of Moodle, once you're on your course page, you simply go to add an activity or resource. Within add an activity or resource, you will see page. Click on add a page. Enter the title under name. You can give it the title of your course or the video name. Keep description as is, or you can enter anything. But where you insert the video is here within content, show advanced buttons. Click on HTML, select this entire text, Control V, and simply click on save and display. That's how seamlessly one can insert videos into Blackboard. And Moodle. The advantage of doing so is even if students are off campus, they'll be able to view the videos without having to create a Jove account, and they'll be able to view it within their course page itself. So that's how it looks in Blackboard as well. How does one insert this into Blackboard Ultra? So Blackboard Ultra is slightly different. Go to a video of your choice. Instead of copy embed code, you will select copy URL. Kindly note you select this URL and not the one on top. You go to your course page. In Blackboard Ultra, click on this add sign, click on create, and click on link. You can give it a name. And under link URL, simply paste it and save. That's how seamlessly one can insert these videos within your course pages. And now, as I said, you can create your own playlist, or you can always use our ready-to-use playlist, and you can insert that entire playlist in one go into course management system. Let me showcase. So first thing, if you have created a playlist, it will feature within your name here. But if you would like to create a ready-to-use playlist, you go to Faculty Resource Center in red here. You have videos mapped to your courses and teaching labs, but you also have videos mapped to your textbooks. Let's look at physics. Several textbooks here. Let's take a look at Griffiths. Basically, what are these? It's a textbook. Basically, not the textbook, but Jove videos aligned to the chapters within the text. So, for example, let's look at Chapter 6, Energy and Oscillations. Several videos from the Jove platform have been aligned to topics within energy and oscillations. All you have to do, you will find this download CC option. CC stands for Common Cartridge. Once this file is downloaded, simply go to Blackboard Ultra. Click on this add symbol here. Click on create and click on SCOM packages. Upload. From your downloads, you click copy it and simply, once this is finished uploading, you will click on save. Just before that, you will have grade SCOM, which you will uncheck since it's not an assignment or test. Click on save. This is how it's done within Blackboard Ultra. How does one do it in Blackboard, normal Blackboard? On the left navigation bar, you will see packages and utilities. Below that, you will see import package and view logs. Next step is import package. Browse through local files. Upload the file. And within select course materials, select all and submit. That's how it's in Blackboard. And you just have to refresh this page. For Moodle, what one does is you go to a topic or a list chapter. You go to the same step as far as add an activity or resource that you will see here. And within add an activity or resource, you will see something known as IMS content package. Click on that. Give it a name. And here within content, choose a file. Choose a file within your downloads. And upload this file. Save and display. And that's how seamlessly you can insert an entire package, be it one video or be it 100 videos, all in one go, making it easier and seamless. And students can simply come into the Moodle course page and simply watch it wherever they may be. Similar in the case of Blackboard, the videos that were uploaded will feature at the extreme end. If you click on this, you have all the videos here within Blackboard. which gets inserted as different pages. You can also edit the page and also move the page within Blackboard, within your course. As far as Blackboard Ultra, you'll simply click on this and click on Launch Course. And this is what it looks like. So all videos within your course page, video as well as the chapters, as well as the reading along with it. So that's how seamlessly one can insert all these videos. Similarly, there are our education videos come with quiz banks if you'd like to know, which can be inserted into various LMSs. If you'd like to know more about this, simply get in touch with me. My email address, I am just sharing it on the within chat. It's Abigail, abigail.souza@jove.com. Thank you so much for your time. I'd like to thank also Dr. Josh Robinson, for dedicating his time in showcasing how Jove videos have enhanced his courses. I'd also like to thank my colleagues, Stephen and Preeti, for on helping out in today's session. Thank you so much, and thank you for being a wonderful audience. Thank you for your time, and see you. Until next time, take care. Have a nice day. Bye bye.